Our last section of the semester is nonlinear systems of equations. So we want to solve a system like this: 3x minus y is equal to negative 2. 2x squared minus y is equal to 0. The first equation, equation 1, is equation of a line with positive slope. If you solve it for y, you have that line there. And if you look at the second equation, it is the equation of a parabola. It's opening up and it has a vertex at the origin. So we see that this type of problem should have two solutions. Our technique to do this is, again, substitution or addition or elimination. So as much as we can, I'm going to use the elimination method to eliminate a variable in order to get our equation in terms of just one variable. Notice we have x squared, x, y, and number terms in this problem. So the way I like to organize my work is to kind of list all of the different types of terms that we have across the top here, and then to rewrite my equations so that the terms line up underneath the terms of interest. So the first equation has x's but no x squareds, y's, and numbers. The second equation has x squareds but no x's, y's, and numbers. So what we want to do is we want to eliminate the y term here. Okay, we're being a little bit lazy here. If we want, we could just change the signs and work it out. But I will multiply the first equation by a negative 1, giving me negative 3x plus y is equal to 2. And now use the addition method to eliminate a variable. The 2x squared carries down, minus 3x carries down because there's nothing here, and nothing here. Negative y and positive y cancel out, and 0 and 2 give me 2. So what we have now is some kind of quadratic with x squareds, x's, and numbers. So if we rearrange it, we have a quadratic form, and we hope that it factors. If it doesn't factor, or if we don't want to take the time to think about whether or not it factors, we could just use the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a, and then simplify it with our order of operations, leaving us with two solutions for x. X equals 2 or negative 1/2. Now, the goal was to find these points. So it looks like x equals 2, x equals negative 1/2 gives us those x values, but we still need the y values. So we're going to substitute those x values back in to either equation 1 or equation 2 to find the y values. Looking at equation 1 and equation 2, it's probably easier to work with equation 1 than it would be to work with equation 2. So we'll substitute it back in to equation 1. If x equals 2, then the y equals 8. So our first point that we have, our first solution, is 2, 8. Then, if we allow x to be a negative 1/2, substituting it back into equation 1 again, and working it out, solving for y, we get a positive 1/2 for y. Thinking back to our graph, do these numbers make sense? 2, 8, negative 1/2, 1/2. Looks reasonable for the type of picture that we have here. And that is our first example of systems of nonlinear equations.